Hello everyone, and welcome to this webinar on pioneering the future of energy storage in emerging markets. My name is Franny Flinterman and I'm project manager at Solarplaza and in charge of the Future of Energy event we will be hosting on the 29th of February and the 1st of March next year in Amsterdam. For those of you who don't know Solarplaza yet, let me quickly introduce us to you. We are a global event organizer based in Rotterdam, the Netherlands. We specialize in PV conferences. We've hosted numerous events around the globe and have a network of over 60,000 PV professionals joining us at those events. This webinar of today is part of the run-up to our Future of Energy event. Which we will host in Amsterdam in 2024 in close cooperation with FMO. Please check out our event website for our program, topics, and excellent speakers we have confirmed so far. Then a few practical notes I would like to share with you before we get started. Please do share your questions to our speakers in the question box that you will see on the right side of on your screen. We will answer all the questions after the presentations. You can also use this question box for any technical issues you might encounter. Our staff is here to help you. And of course, we will record this webinar and we will share the presentations and the recording in a couple of days with you. So our moderator of this webinar is Michel Scheepens. He is Manager Energy West Africa and MENA region of within FMO. So Michel, please join us. Welcome to the webinar. Yeah, the floor is yours. Good luck and enjoy the webinar.
Thank you very much, Franny. Welcome all energy friends. It's good to have you today in this webinar. This webinar we organized on energy storage, basically as a warming up to the Future of Energy conference. Indeed, we are organizing together with Solarplaza next year, February, in Amsterdam. For today, Solarplaza has organized a very interesting program, bringing together, I would say, different perspectives in the energy storage domain. We have a project developer, that's Gilles Parmentier, founder of developer Africa REN out of Paris. We have Roberto Rodriguez Labastida, market consultant working with Guidehouse Insight in London. Roberto will provide us really with an overview of the global trends in energy storage. So that's basically broader than just battery storage. Again, Gilles Parmentier joining as a developer and helping us in understanding the struggles he as a developer has encountered in developing his first energy storage projects in West Africa. And finally, but not least, we have Peter Mockel from IFC to help us in better understanding today actually the challenging from a financing perspective in financing energy storage / battery energy storage projects in emerging markets. So I think that summarizes a bit who we have in the coming hour ahead of us. The idea is there will be 10-minute presentation by each. At the end of each presentation, there is room for some Q&A. So please, you can fill that out, as Franny said already, in the chat box, and we will try to summarize the questions at the end of each presentations. Whereas in the end, there is a 15-minute Q&A, a general one. So without further ado, let me further introduce you indeed Roberto Rodriguez Labastida. He's a principal research analyst. Hi Roberto, good to see you out of London today. I think, the same kind of stormy weather as we are witnessing here in the Netherlands. Good to see you, Roberto. You bring in more than 10 years of experience as market consultant, strategy consultant in the energy domain. And of course, the last years very focused on energy storage. So without further more words from my side, yeah, Roberto, the floor is yours. Happy to hear what you can bring us.
Thank you, Michael. Thank you. Sorry, cannot move the slides, so we can go to the next. Can we go to the next slide, please? One more. So in this presentation, I'm going to cover a little bit of what we do in Guidehouse Insights in the energy storage space, talking about our tracker, and then going to the different regions that we consider emerging markets to just highlight some of the trends we're seeing, quantify what's the opportunity in these markets, and finally just give a couple of views from my side. If we go to the next slide. So we've been covering at Guidehouse Insights, we've been covering the energy storage space for more than 15 years now, and we launched our tracker more than 10 years ago. Currently, we have a little bit under 8,000 projects in it, and I'm very pleased to see that emerging markets cover a significant part of that. In this tracker, we track all the energy storage technologies. If you go to the next slide, I can show a little bit more about that. We also track how the batteries are used. We cover the whole world, and you can see a little bit about the methodology there. And we try to cover behind the meter and utility scale system deployed. I would say for behind the meter, this is the larger ones, obviously not residential or small commercial applications. Can we go to the next slide, please? So yeah, as I said, we're covering just under 8,000 projects at the moment. 40% of them are in emerging markets. That's Asia Pacific, Middle East and Africa, and Latin America. And APAC, we exclude Japan and Australia from the emerging market definition. We do include China and South Korea. In our tracker, 4 out of 5 countries are in Asia Pacific. Two are considered emerging markets. In this case, China and India. The other 2 are Japan and Australia. And in terms of capacity, what we have seen is the pump hydro. It's still the most deployed technology in emerging markets. There's a significant amount of that in China, India, Brazil, and other markets. But if you look at what is actually growing, you see that batteries are where the growth opportunity is. And specifically for Africa, we expect around 25 gigawatts of energy storage, but mostly battery capacity to be added in the next decade. And in terms of what's stopping this, instability, corruption, lack of information about energy storage, and financial barriers are still the most significant. But let's deep dive. Can we go move to the next slide? So this is a little bit of what I was talking before. As you can see, in emerging markets, we have around 165 gigawatts of pumped hydro installed, just under 60 gigawatts of battery capacity. And then we have some unknown or undisclosed thermal, hybrid, and surprisingly, things like ultra capacitors, case, and wave technologies. Can we move to the next slide, please? So this is our deep dive into Africa. As you can see, South Africa is the leading market, and pumped hydro is also the leading technology. But Egypt, Iran, this in the Middle East, Morocco are also interesting markets, and in Africa, Zimbabwe and Mali and Chad are also seeing some capacity installations. And one of the, I would say, main trends that we have seen looking at the data we have is a significant amount of remote or weak, what we call weak grid installations, where you create microgrids to at least partially rely on local resources instead of waiting for the grid. And that's common in industrial and mining applications in Africa. And another trend, more recent trend, is mostly South Africa, and the problems that ESCOM has been having in the country with outages and things like that have driven an interesting distributed energy market, including energy storage for businesses and for, I would say, the wealthier population looking at solar rooftops batteries, for example. Can we move to the next slide, please? Asia Pacific are dominated by China and India. Especially China has a significant amount of energy storage. I mean, in China, the story is more similar to what we see in the developed world, where the batteries are used as either non-wireless alternatives or some arbitrage application, things like that. In India, it's a mixed market where we also have a significant amount of remote microgrids or weak grid microgrids, but also we're starting to see some more traditional utility energy storage applications or distributed energy resources in commercial and residential applications. And in this case, we don't include any of the truly microgrids or home solar and batteries where you really have a very small battery at home. Sorry, again on Asia Pacific, another trend is the country island countries, Philippines, Indonesia, Taiwan have pushed local microgrids for these islands, and they're using these installations of wind, solar plus batteries to reduce the amount of diesel that is using to power these islands. It's very expensive to bring diesel to some of the medium and small islands, so energy storage plus renewables have taken a significant market there. In Latin America, Brazil dominates, as I said before, but in Brazil it's been mostly pumped hydro installations that they've been installed in the last 50 years or so. It's not that much of new capacity. we are seeing some new installations after they introduced a short-term electric price model in 2021. But that's still the market is still dominated by pump hydro. Another interesting market in Latin America is Chile, which is a small country compared to some of the neighbors, but they were one of the pioneers in renewables. They're also one of the pioneers in renewable tenders with a time component in it. So you bid for I think 4-hour slots, and that was introduced more than 5 years ago, and that created an incentive to install batteries along your renewables when you were bidding in those tenders, because first, obviously, that's the only way you can maximize your revenue, but also helps you avoid penalties if you cannot deliver what you are promising. We saw the largest installation in Latin America happened in Chile. It was completed in July this year. It's a, I think, 5-hour, 112 megawatt system that they installed. And this system is an interesting one because it's allowing to manage the transmission line that exists between the north of the country and where most of the renewable resources are, and the center and south where most of the demand is. So they are using those batteries to time delay or time shift the utilization of the transmission lines there. Other countries in Latin America, Mexico has some distributed energy markets thanks to the shift away from net metering, and Colombia is also seeing some developments of energy storage, mostly for arbitrage applications, energy arbitrage applications. So some of the markets and drivers that we're seeing, as I mentioned before, I would say most of them are very similar to what you see in the rest of the world. Growth in renewables. Luckily, a lot of these markets are blessed with very high renewable resources, solar especially, but also in some places wind. They also are interested in tackling decarbonization of their systems, and I would say also economically, renewables are becoming very attractive. So it's not only the decarbonization part, but also just an economic driver. There's also a need to improve the grid, and I think they're more open in some markets to alternatives like microgrids and other technologies that reduce the need for large grid installations. And also, it's a way to reach populations that are not currently electrified, but need to be brought into the grid, or into or providing some electricity services. And finally, they are looking at so these are some of the markets where extreme weather events happen regularly. I'm from Mexico, and we just had a high capacity category 5 hurricane in the southern coast that had a significant damage on the grid. It's been around 7 days at the moment, I think, without electricity. So they are looking at ways to bring in some storage systems there to help with that. And the market barriers are the classical financial costs, high upfront capital costs, and especially lack of familiarity with the technology. I think by now wind and solar are understood, and the people realize that they are cheap. But storage is still a topic where people might not be up to date on the costs and the services that they can provide. Also instability, corruption, and one that is not here but it's also a problem is undeveloped energy markets, and this in many countries they don't even have energy markets, or they may have a wholesale market but not ancillary markets, which are a route to market for many energy storage at the moment, energy storage projects at the moment. So looking at the future, we see Asia Pacific still dominating the market. This is annual installation, so you can have an idea. And I would say from Asia Pacific, China takes the lion's share of that. But we see growing markets in all the three regions. And as I said, installation of energy storage comes right after you reach some level of renewable renewable installations in your system. So the market is looking at these technologies. We have seen an increase in interest in those markets as well. And the other trend is a significant shift again away from pump hydro. You can see there's a small yellow strip there, but most of the installations are expected to be lithium-ion. What we think is, or what we are seeing, is that the markets are still far away from the point where they will look at long-duration energy storage, and also because of their location closer to the equator, they might not have significant heat markets where you might need a couple of weeks storage capacity to bridge the winter days like we have in Europe. So the need for long duration storage, we see it as a less issue, or the issue is less than in northern markets or in colder markets. So as I said before, I think I talked about this in my previous slides, but I think we have similar issues faced in emerging markets than in developed markets. So technology, finance, things like that are still a problem. And I think another issue, as I said, is energy markets, how to integrate behind the meter assets, front of the meter storage, etc., and also how to bring new finance. So hopefully Michael can help with that at some point.
Sure. Thanks a lot, Roberto, for this really pinpointed summary of the market developments in energy storage, where I have one question, maybe a quick one to answer. What is, for especially battery storage, the business model you see most in emerging markets today?
It's still mostly microgrid applications, so displacing generation, expensive gensets in islands and weak grid applications. As I said, mining, things like that. And I think we're seeing a shift to energy arbitrage. There are some interesting energy arbitrage projects in Colombia, for example. There are no real incentives there other than the price, but they are project developing just for that reason.
And these are relatively merchant business models then?
Yes,
compared to then basically a fixed fee, capacity payments under a kind of
Yes,
PPA?
There's not that much of that in Latin America. Or in other countries. I think the only one is Chile, where I mentioned the tenders there, where they do have is still energy tenders, but because they have a time constraint on when you have to deliver your electricity, then you need something, a technology hedging tool, I guess.
Okay, super. Again, Roberto, many thanks. Then for this part, let us then go over to Gilles Parmentier. Gilles, you are joining us to give the developer's perspective, I would say, on especially battery energy storage projects. And in your case, the experience you had thus far in especially West Africa, and in Senegal, to name one country. I mean, you're bringing a broad background to the table, first as a banker, financier, investor for over 14 years, and then thereafter you actually co-founded your own developing company. And Africa REN, you founded the company now 5 years ago, where actually thus far your track record has been now impressive. Could you share with us your lessons learned, where Africa REN is standing today, and actually some lessons learned you're happy to share with others?
Yeah, thanks, Michel, and happy to share our experience in developing Wallow storage, which is a storage project in Senegal that we developed for the past few years with the support of FMO of you, Michel. So you already know everything about it, but I will share with the audience and try to drive few lessons from this experience. So a few words about Africa REN. We are a developer dedicated to Africa, mostly Francophone Africa, and we develop renewable energy, storage, energy efficiency projects. Notably, we have developed the first solar IPP in West Africa back in 2016. Last summer, 3 months ago, we have commissioned the largest solar plant in Burkina Faso that we built under a challenging environment. We experienced 2 coups during the construction phase of the plant. And we are really about to start construction of Wallow, which should be the first storage IPP in West Africa. We're about to start. I mean, we are finalizing the few remaining CPs to financial close, and construction should effectively start in December. The first, I like to go broadly about what we call BSS provides. So BSS is battery energy storage system, and the idea is a battery storage can provide various services, mainly five functions. The first one is peak shaving, and that is the illustration here. So it's taking part of the power generating during the day by the solar plant and supply it during few hours later, and mainly during the peak hour around 7-8 p.m. So that is peak shifting. Load leveling is basically increasing the base load of the grid, and that helps smoothing the fluctuations in the power supply. Frequency regulation is also a key function, and it's keeping the frequency within acceptable limits. So it means, I mean, the battery system can rapidly absorb or inject power into the grid to stabilize the frequency when the frequency become unstable due to the intermittency of the generation. Typically with wind and solar, there is intermittency. A battery system can regulate that and prevent outages of the grid. Voltage support helps improving the signal of the grid, and so improves the quality of the energy supplied to customers. And grid resilience is whenever there is a blackout on the grid, the battery system can help the black start and accelerate the grid to make it operational quicker than without the battery system. So these are the 5 main functions of storage. And actually, our project in Senegal provides those 5 functions in not exactly in that order. The most important one is the frequency regulation, then the load leveling, the peak shaving, and the grid resilience. So Wallo will be located north of Senegal, adjacent to Mauritania, and the reason for the project is the increasing share of renewable energy in the energy mix of Senegal. Namely, they now have a dozen solar plants on the grid and a very large wind farm, and that creates intermittency and urgent need to stabilize the grid. So we developed with the Senegalese utility, Wallo, which will consist of 10 megawatt, 20 megawatt hour. So it's 2C batteries, 10 megawatt during 2 hours maximum. And it will also be accompanied by a 16 megawatt solar plant. The idea is that the solar plant will supply the batteries, and we will not take power from the grid to supply the batteries. It will be lithium ion, and the 10 months construction should start in a month now, from now. So it is structured as an IPP, plain vanilla IPP. We have an SPV that signed a PPA with the off-taker that benefits from a sovereign guarantee from the government. We provide equity. Our friends from FMO and Emerging Africa Infrastructure Fund provide the debt. The plant will be installed by an EPC contractor and will provide maintenance services. So fairly similar to what we would do for a solar plant, except that we don't sell kilowatt hour, we don't sell energy, we sell a service to the grid. So what can we learn from developing the project over the past years? First, and it may be obvious, there is no regulatory framework in most of African countries for storage, simply because there is no storage. So it is fair that there is no regulation yet, but it means that the regulator has to determine what is storage. Is it generation of power, or is it transmission of power? And that leads to few consequences that needs to be clarified early in advance. Like, do you need a generation license? What is the procurement process, etc. It may not be the same whether you are qualified as generation of power or transmission of power. Another important feature is the integration into the grid, and in particular with the dispatching of the off-taker is absolutely key. If we want that system to work efficiently, the integration with the dispatching must be absolutely smooth, and they must have instant control over the batteries. The batteries should discharge automatically or take offset power automatically, but also at the demand of the dispatch, and it should be done within seconds, really, if we want to provide the service. A very important risk is the climate conditions in Africa, in other regions of the world, of course, but in the Sahel region, temperature can go really, really high. There is a lot of dust, and batteries don't like that at all. And that can affect the performance of the batteries, can affect the lifespans of the cell, and it should be very carefully monitored. Make sure that we have all the air conditioning with the right dimension in place to prevent any damage to the equipment from the high temperature. Also, batteries can, I will not say can be dangerous, but in case of fire, it's a different story, and it's certainly not the type of situation that local firemen are used to face. And it is also the responsibility of developers to make sure that the local firemen are appropriately trained to face this type of situation, and that they know how to react in case there is an incident on site. Something that raised a number of important issues is the actual tenor of the contracts. On our project, we combine storage with a solar plant, and that created a number of confusion because the regulator was unclear whether we were generating power or transmit power, as I said previously. But then you also, if you combine solar with storage, you need a long-term PPA for the solar, typically 20 to 25 years, which is not the useful lifetime of the batteries. The batteries will degrade faster than the solar plant, and it means that logically the duration of the contract for the batteries should be shorter than that. It should be 10 to 15 years, which match the warranties that will be given by the suppliers. So one of the issue we face at the moment is a tendency to try to combine solar and storage, which means combining two technologies that do not have the same lifetime. And I strongly believe that we should do solar wind project with 20 to 25 PPAs, and we should do standalone BESS project with shorter PPAs. Another issue we faced was on the equipment, the supply of equipment. Most of the equipment, at least the cells, come from China, and that raises issues on the labor force. It also raises issues on the supply chain for the lithium and the mining condition that supplies the lithium. And so very early in the process, developers should be careful about the sourcing of equipment and making sure that we fully comply with all ENS standards. And the last lesson is, for me, I would say, is we collectively need to build capacity on BSS, build knowledge to the regulators, the off-takers, and also emerging markets should benefit from the experience of more mature markets like the US, Australia, Europe. And it's also part of, I think, the role of DFIs to make sure that, you know, we don't reinvent the wheel in emerging markets, and that risks that have been identified and mitigated in other regions of the world benefit, you know, emerging market benefit from that experience to fast track and accelerate the development of projects.
Okay, Gilles, many thanks for this and really sharing your lessons learned. Where, yeah, I would like to pose maybe one question. I mean, from your perspective as a developer, what would be the sole thing that really would make the difference? If you have to name one, you already talked about educating maybe regulators, national utilities in the application of battery storage, but to get more of these projects off the ground, especially in Africa, what would you name as the points to tackle?
It's quite difficult to answer the question. What we see in reality is most of the time, off-takers see a storage project as generation, and every time we come and try to offer a solution to a problem they have on the grid, they ask us the price in terms of kilowatt hour, and our answer is to tell them we are not selling power, we're selling a service, which means it is euro, dollar per year. We provide a service.
Yeah.
It's I mean, in terms of you converting the tariff in kilowatt hour, then the conclusion is inevitably storage is not affordable.
No.
It's not affordable as a source of generation, but it will save so much on the cost of outages, etc. That yes, it is. It provides value for money, but it does not provide value for money as a source of energy. And that is the major misunderstanding we may have with utilities.
No, loud and clear. Yeah, really much more education to happen, especially for the end users. These very useful systems.
Yeah.
Thanks a lot, Gilles, for the moment. Then I would like to turn over to our final speaker this afternoon. That's Peter Mockel. Peter, welcome again. You actually are working right now as a principal industry specialist on energy storage at IFC. Before that, you have been active as chief technology officers in a number of capacities, including Deutsche Telekom, and earlier as consultant at Booz Allen. Have as well co-authorized a number of articles on applied technology and innovation management earlier in your life. But right now, I mean, you are within the World Bank Group IFC, one of the experts on energy storage. So could you help us today in some further understanding the issues you see in terms of bankability and financing of these projects? over to you. Please.
Thank you. Thank you very much, Michel. Thank you for having me. I won't spend too much time on IFC. Just suffice to say, IFC is the private sector part of the World Bank. That means we bank with private sector entities in emerging markets in a double bottom line capacity. So we are for profit and we need to have a development impact in energy storage. That means that we provide both project finance and corporate finance for to bring energy storage to deployment in emerging markets. And I will now try and advance my slides. So quickly, let me talk to you about how we see the market, what we're seeing in emerging markets right now, and what's our view of bankability. Clearly, we're bullish on energy storage. More renewables require more energy storage. Lithium-ion batteries will be the main bankable technology for the next few years, and we focus on that. It's a mature and established technology that's technically de-risked, but still new to many investors, and we need to inform investors, including ourselves, that this is now bankable. Use cases are complex, and we see all of the above. So there is no typical solution at this point, and we try to streamline the structuring of energy storage investments to make transactions less risky and more and faster and have lower legal costs. The market is clearly sort of purged after we saw an increase in cost during the pandemic and the subsequent supply chain problems. It's now purged, in my opinion, at the beginning of a renewed fall, maybe that's just my personal opinion, by another about 30% by the end of the decade. And most of the growth you see in the lower chart will come from emerging markets, whereas the big markets now, like North America and Europe, will stagnate more or less, still add a lot every year, but we see most of the exciting growth in emerging markets. So you see that there's a number of projects under development in emerging markets today. In the hundreds of megawatt hours, a lot of them. But the sizes are maybe a few years behind what we see in OECD countries like North America. That gap is shrinking. A lot of it is concentrated in a few markets. I personally think the key determinant is the regulation, in that you have regions, and we heard that before, like Latin America, where there's a lot of battery storage in Chile. Let's not talk about pump storage for a moment. Battery storage in Chile going on more than in most other countries in the region, and a lot of that has to do with the right regulatory framework. Similar in other regions, in a lot of projects in the Philippines, more than in all other neighboring countries, probably due to the right regulatory environment. So the highly concentrated growth at this point, but it's beginning to spread out into the wider regions, into other emerging markets, which is good news. And we saw that with Gilles in Africa. It's not just South Africa anymore. In Latin America, it's not just Chile anymore. The one key problem are still delivery times. The rules used to be about 6 months from signing to commissioning. Now we're talking about more 12 to 18 months. We think with more production capacity coming online after 2024 and 2025, the situation will improve, and the delivery times will shrink again. Because there is a lot of capacity being built for battery manufacturing. Technology mix is now predominantly LFP. We haven't seen anything without LFP in quite a while. It's even though here when you see market data from analysts, you still see a good part of NCA or NMC. I haven't seen anything that's not LFP for probably 2 years. Other than that, technology is lithium-ion will remain the main play. Long duration energy storage, flow batteries, etc., are technically also mature, but not really subject to project finance in a big way. maybe that's about 2 years out. Sodium-ion batteries will come in at the low end for stationary, but they also have their own supply chain to ramp up, so it will not take a major part of the market. And then solid-state batteries are more for the EV folks, because in the stationary we don't really value high density that much. Quickly trying to hurry this up. A few examples of what we're seeing in interesting projects. So one interesting phenomenon is that until very recently, until the IRA, to get the investment tax credit in the US, you had to co-locate renewables with batteries. So you saw a lot of co-location that wasn't technically driven, but more tax incentive driven. In emerging markets, there isn't that incentive, so we see a lot more variation in configuration. For example, standalone for a transmission deferral in Colombia on the left-hand side. It's an interesting one. We see in Chile a lot of renewables integration. We see on islands, I think that's a theme I'm very excited about, that on islands, it's clearly profitable out of the box to replace diesel or heavy fuel oil with solar and batteries. And we see a lot of those being proposed. Mauritius here, for example, and then IFC has been advising Uzbekistan to procure grid storage for solar integration. That's clearly another trend that countries have been very ambitious with rolling out solar and also wind to a lesser degree, and now that drives the requirement to add storage. Finally, being aware of time, so part of my work is try to make sure that IFC has a streamlined process for processing energy storage opportunities, both in corporate finance and in project finance. And some of the things that we particularly pay attention to on the technical side are degradation. So a good view on the duty cycle, good prediction of the degradation, and a plan in place. Either it could be part of the contract to just run down the battery in a predictable way, in a defined way, or it could be to keep capacity constant and then come back for augmentation. And there must be a good plan in place for that. There must be a good view on the lifetime of the battery. So over about 15-year expectation, we pay particular attention to it. We've seen tension there if the tenor of the project is longer than the assumed lifetime or the warranty for the battery. That leaves a risk at the tail end of the project. So how to deal with that is an issue. And then finally, what we advise on our clients that we work with, for example, developers, on making their projects bankable, is to pay close attention to tier one vendors. There isn't really a tightly defined definition of who's tier one as there is in solar. It's a younger industry. But both on the integrator side and the cell manufacturer side, I think we have a good view on who these are. So we'd advise use of tier one. Oh, and as with solar, there will come a time where it will make sense to consider a calculated risk to use lower cost equipment from lower tier vendors if that's a calculated risk. That time is not now in storage. We would still advise everybody to stay with high quality vendors and not optimize too much on the price side and take a quality risk. In technology, LFP is the technology of choice to avoiding all supply chain issues with cobalt origination, for example, or also nickel processing. And you need one EPC, one throat to choke, not a split in responsibility between the renewable and the battery part for co-located systems. Very clearly defined duty cycle, view on degradation, and warranties at least 15 years. A clear plan on safety. But really, the real risk isn't really unplanned degradation. The real risk is safety, and that has to be managed. And we heard that before. Very important. Has to be liaised with the local fire brigade, for example. That there's a training in place how to deal with battery fires, and then a useful life has to be properly calculated. 10 minutes, that's it. Thank you very much.
Right, thanks a lot, Peter. Thanks a lot for this Yeah, I think there are a number of questions as well by the audience, and one is more a generic one, and maybe it's good that we take them directly to the general, so the plenary Q&A. So with Gilles and Roberto as well joining now, because that's the question about if you talk about the technology and the batteries themselves, what has been the experience indeed in the servicing of the batteries? Is there local servicing available in most markets already, or do the batteries really have to be taken out and shipped back to China for inspection? How can you then still make sure your project is running as it should be? Who would like to reflect on that one?
I can talk a little bit in a general view. I think what we have seen that it's failing the most is the PCS part of the batteries, and that's something that can be managed on site either by servicing teams or local teams replacing those. There is the same with solar inverters. Is probably the critical part of these installations.
So it's partial replacement on site that can happen. That's what you're saying, right? And you don't have to.
Yes.
And Gilles, as well, your experience thus far in selecting the battery supplier. What are then the critical criteria amongst next to the guaranteed tenor, of course? But
you're right. I mean, operating the batteries is key, and particularly in emerging market, we happen to be in remote areas far from the factories where the batteries were made. Some suppliers have what we call open systems, where you can replace, you can do maintenance on site, you can open the container and do maintenance yourself or with appropriate technical people. Some others have a different strategy, which is the black box strategy. You don't, in case there is a problem, you don't open the container. You take it and ship it back to the factory. And that can, in the end, cost a fortune, because when it takes 1 month's boat to ship the battery back to the factory, they repair it, ship it back to Senegal or another place in the world, whereas you don't provide the service or the full service during that time, in the end, that can prove to be a bad strategy. So again, in part of supplying the equipment, the maintenance and how the maintenance will be done is key.
Yeah, no, understood, Gilles. Yeah, understood. To conclude the presentations now, may I ask each of us to think about one key element where in your capacity, and then I'm turning first to Peter, as basically a financier in the end, what would really make the difference in making financing this asset class easier from a financier's perspective? You would have to name one.
Yeah, one thing we're trying to push is to have more standardized PPAs, in that there's still a high legal cost. There's a big variation of different PPA types, so you still have to get the lawyers in, have a high legal cost, perceived higher risk. So whereas in solar, there's a high standardization, and I think we need to converge on more standardized ways of doing business in storage to make it faster and cheaper.
Right, clear. And Roberto, from your perspective?
I think legislation is probably one of the key issues at the moment. Even in Europe, if it wasn't because of the Ukrainian crisis, the energy storage market will still be in its infancy, right? So now translating that to emerging markets, that they don't know how to treat a battery, and that's a massive issue. And as Peter said, Chile has done a great job, and that's what you see development there, for example.
Yeah, understood. Regulation, you're saying clearly. And Gilles, from your perspective,
I think what this is the most at the moment is a way to adequately compare technology services between one another. I mean, for solar, for wind, it's easy. You sell kilowatt hour, so the key criteria is the price. For storage, the price means nothing. You have to link it to the service, the level of service that you provide. For the same capacity, you can have more megawatt hour, less megawatt hour, different type of services, and that makes it very difficult for the governments and utilities to choose between different proposals from different developers, different technology suppliers, and we need to help them. We need to educate, train people, etc., so they really understand what is beyond the price and make sure that effectively they get value for money.
right, loud and clear. Loud and clear. Thank you very much all for contributing. And with that, I would like to hand back to Franny to round off the session, please. And wishing you all well.
Thank you, Michel, for moderating this webinar. And thank you, of course, Roberto, Gilles, and Peter for your insightful presentations. And thank you to the audience for joining us today. We would love to continue the conversation with all of you on storage at our event in Amsterdam next year. So please, when you want to schedule your attendance and buy your ticket for the conference, please do use this discount code when registering, and then we would love to welcome you in Amsterdam in a couple of months. Thank you all, and see you then. Bye-bye.
Thank you. Bye-bye.